Hi, Dr. Shmaila here, your physiotherapist, your mentor. Today, we continue with chapter number 1, that is mechanical principle, and this is last section of chapter number 1. Now discuss pendulums and elasticity. First of all, we start with pendulum. Pendulum. What is pendulum? Basically, if you look at the definition, a simple pendulum is a heavy particle suspended by a weightless thread and free to move to and fro. When the pendulum is at rest, the thread or rope is vertical, but if the particle is drawn to the one side and then released, then we will look that pendulum will swing to and fro. One complete swing in each direction is called oscillation, and extent of the swing to any one side from the vertical is called amplitude. A force is required to set the pendulum in motion, and then the oscillation will continue until it is brought to rest suddenly by an opposing force or progressively by the resistance of air. The time taken for each oscillation is determined by the length of the pendulum and the acceleration due to gravity. Now, what are the pendular movement? Pendular movement basically in the human body occur chiefly at the shoulder and hip joints when the muscles are relaxed and the limbs distal to the joint swing loosely to and fro. Muscular contraction may be used to initiate the movement and to maintain or increase the amplitude of the oscillation, but it is minimal compared with that required to perform the same movement at any speed greater or less than that of the pendular swing. Obviously, this is done in the human body. For example, leg is carried forward by a pendular swing of the leg from the hip joint during slow, easy walking, and the same type of the movement occurs to some extent at the knee joint. Arm swinging exercise at natural speed can also be done in cases of the marked muscular weakness without fatigue when slow or rapid movement is impossible. Arm swinging exercise are best example of pendular movement. We can perform these movements um, in sitting or in lying position. When you are in sitting, then say the patient hang your arm loosely and then move the arm to and fro slowly in each direction. Basically, this is pendular movement. And if the patient is in prone lying, then took him to the edge of the table and then his or her arm hang loosely over the edge of the table and say him to move, swing his arms slowly to and fro in each direction. This is basically pendular movement, and this is also known as Godman exercise. We can perform it in various cases. For example, in the case of the frozen shoulder, pendular exercise are very helpful in the initial stages. Suspension. Look at suspension. Basically, what is suspension? Treatment or therapeutic exercise given to the patient to increase range of motion, increase muscle power, and support body parts by using ropes and slings. What are our aims? Muscle strengthening and neuromuscular coordination. Types of suspension: three types: axial suspension, pendular suspension, and then vertical suspension. Now start with axial suspension. A limb supported by a rope suspended from the point vertically above the joint to be moved is said to be axial suspension. That is, the point of the suspension is vertically above the axis of movement. When the limb is relaxed, it will rest with the joint in the neutral position, and when the movement is initiated, it will swing freely to either side of the resting position on a plane which is horizontal. Basically, an arc of movement is formed at the base of cone, we can say arc of movement basically forms a segment of the base of the cone, the radius of which is equal to the length of the limb, and height of which is equal to the perpendicular distance between the joint and the point of the suspension. This is axial suspension. Basically, in axial suspension, um, basically limb is supported by the ropes, and the point of suspension is vertically above the axis of the movement. Now, what is the advantage of this type of suspension? It is the most common type. Joint is taken as the point of suspension, gravity eliminated, and limb is supported by the sling above the joint, and you can say limb will move to both sides parallel to the floor. Um, Very helpful for physiotherapist because it frees her hand, and he perform his other duties beside supporting heavy part of the limb. What are the uses of axial suspension? Relaxation. It maintains muscle property, increase blood circulation, and obviously it increases venous and lymphatic drainage. What is pendular suspension? Movement in the pendular suspension. Basically, this type of suspension represents a lateral or medial displacement of the point of the suspension from the position which it occupies in axial suspension. In this case, limb no longer rests in the neutral position of the joint but falls to new resting position which lies towards the vertical plane, contribute to the new point of the suspension and the joint in question. Movement on either side of the resting position causes the center of gravity of the limb to rise, making possible pendular movement. As you know, pendular movements are to swing to and fro movements, and if you look at pendulum, then you can see that when the free particle move to and fro, then when it moves to one side, then it achieves a new point. So in this is similarly this is the case in pendular suspension. Movement on either side of this restive position causes the center of gravity of the limb obviously to rise, making possible for that pendulum movements. Thus, in comparison with axial suspension, if we compare it with axial suspension, we can say muscle work required to produce movement away from the resting position is increased, but none is required for the return of the movement. The effect of this type of suspension upon movement from the resting position is similar to that of inclined re-education board, which supports the limb during movement up to the incline, but differs from that in pendular suspension. We can say friction is usually eliminated because limb is supported by slings and ropes. So friction is completely eliminated in pendular suspension, but it looks very similar to an inclined re-education board. Now, what are the uses of pendular suspension? Increase the muscle strength, increase the muscle endurance. Basically, movement of the lower limb at the hip joint provides a convenient example. Suspension of the limb from the vertically from the point above the hip joint, that is in axial suspension, rest it in alignment with the trunk, and the movement into abduction or adduction take place in a horizontal plane. When the point of suspension is moved medially, pendular suspension, then we can say limb falls to rest in adduction, and movement into abduction requires effort and is accompanied by some flexion as the center of gravity of the limb is raised from the resting position. If we release the limb, if the limb is then released, it will fall passively into the adduction automatically. What is movement in the vertical suspension? Basically, in vertical suspension, center of gravity of the body part or body is taken as a point of suspension used to provide support to the body parts of the patient, used to for relaxation and to prevent the pressure source. This is all the uses of vertical suspension. Now, what is elasticity? Elasticity is the property of a body which enables it to regain its original form after it has been distorted by the application of the force. Whenever in elasticity, whenever you release the force, then it comes to it, when it comes to its original shape, then we can say it is elasticity. Basically, the application of distortion in shape by the application of the force is known as stress, while the quantity, that is the change in the length per unit length, is strain, which measures the extent of the change in size or shape. Hooke's law states that strain is proportional to the stress producing it so long as the strain is not too great for one so-called elastic limit is passed, permanent deformation occurs. Springs, rubber elastics and sorbo rubber all possess the property of elasticity and are in common use in physiotherapy. Now look at them one by one. Springs. The spiral springs use either to resist or assist the force of muscle contraction or to produce passive movement of the joint. Consists of a uniform coil of the wire which is extensible. The extensibility of the spring. A spring can be elongated by a force applied at one end of it in direction of its long axis, the other end of the spring being fixed. The increase in the length of the springs is directly proportional to the magnitude of the applied force used to stretch it. Weight of the spring. The standard springs which are used are graded as, for example, 50 lbs, 40 lbs, 20 lbs, etc., according to the bondage which must be applied to them to stretch them to the predetermined length. Length is indicated by tape inserted within the coils of the spring. The tape becomes taut when the maximum length is reached. The tape also basically serves to prevent the spring from being overstretched and consequently damaged. Basically, a tape measure that coil of the attached within the coil of the spring, and when spring attains its maximum length, then it automatically comes taut. Thus, an applied force of 40 lbs is required to stretch a 40 lb spring to its maximum length. The weight of the spring is determined by the material and thickness of the wire from which it is made and the average diameter of its coil. What is the recoil of the spring? When the applied force which stretches a spring is removed and spring returned to its original length, the potential energy stored in it during extension is released as kinetic energy, and almost all of this appears ultimately as heat in the coil of the spring. Oscillating movement produced by the spring. If the weight applied to stretch a vertical spring is raised and then released again, an oscillating movement is produced by the spring, the amplitude of which decreases progressively until the spring comes to rest in equilibrium. Now, there are two scenarios when we use spring using parallel and spring using series. Spring using parallel. When the spring of a specific weight is not available, two equal springs of half the required weight may be used in parallel to produce the same result. For example, you can say two 40 lb springs arranged in parallel are equal to a single 80 lb spring in series. The weight of the two equal springs arranged in series is the same as that of a single spring, but the amount by which they may be extended in order to reach the limit of the extension is double that required for a single spring. Thus, when we can say, look that when two 40 lb spring arranged in series are extended to an amount equal to that required to stretch one of them to the limit, each of the two spring is only halfway extended, and the applied force needed to achieve this is therefore 20 lbs. So I hopefully you understand this, that what is the difference between spring used in parallel and spring used in series. In parallel, when we say that spring used in parallel, then we can say that if we use two 40 lb springs that in parallel, then basically we can achieve the result 80 lbs. But different in the case of the series springs arranged in series, the weight we look at here, that weight of the two equal springs in arranged in series is the same as that of a single spring, but the amount by which they must be extended in order to reach the limit is double than required for single spring. So we look at here that when two 40 lb springs arranged in series, they only stretch halfway extended, and the applied force needed therefore be 20 lbs. What are the rubber elastic? Rubber elastic of different thickness may be used in place of the springs, and in many ways it is more suitable for providing light assistant or resistant exercise. Sorbo rubber. This material is both compressible and extensible and is used for providing light exercise for gripping movements of the hand. Well, this is all end of the chapter number 1, that is mechanical principle. Hopefully you all like it and hopefully you all understand it. Thank you.